Alrighty, so in this video we're going to look at taking the derivatives of exponential and logarithmic functions. The first one I'm going to start off with is y equals e to the x, the most obvious exponential function. So to take the derivative of this, I'm going to do the limit definition of the derivative. So we'll take the limit as h is approaching 0 of e to the x plus h minus e to the x divided by h. Okay, now e to the x plus h can be split up into e to the x times e to the h. So we'll do this is equal to limit as h is approaching 0 of e to the x times, and if this is e to the x times e to the h, we can factor out an e to the x out of here. So that's what I'm going to go ahead and do. And then we'll get e to the h minus 1, and then that is divided by h. Now I'll try to insert a graphic right here, but pretty much you can use your calculator or just use kind of like a mental, you might call it like a sandwich method. So you can say as h is approaching 0, this term is approaching 1. And so we get e to the x times 1. So y prime is equal to e to the x. Now, this is the only function, which is rather interesting, whose derivative is the original function. So the derivative of e to the x is e to the x. Now, there is a general statement to be made here, and that is that, we'll put it this way, the derivative of e to the u is equal to e to the u times du over dx. Now, in this case over here, du dx would just be the derivative of x, which is 1. So this is the general formula for the derivative of e to the u, and this is the one that you'll need to memorize. Let's go ahead and take an example of this, and then we'll move on to logarithmic derivatives, but go ahead and start with this. So we have y equals e to the x squared. Following this up here, if we have that u is equal to x squared in this case, we can go ahead and take our du. It's going to be 2x dx. Therefore, du dx is equal to 2x. Okay, and if this is our du dx and y prime is equal to e to the u, we have e to the x squared times du dx, which is 2x. And that's our answer for this problem. Okay, so let's go ahead and move on to logarithmic functions. Okay, let's set it up like this. We have some function y which is equal to the natural log of x, and we want to know what the derivative of the natural log of x is. Well, there is something we can do to both sides. If you recall, there is a property that says e to the natural log of x is equal to x. And we can actually use this property on this equation. Oops. Go ahead and use this, and we can simply e both sides. So we get e to the y is equal to e natural log e to the natural log of x is equal to x. Now, using this, we can go ahead and take the derivative of both sides using implicit differentiation. The reason we're using implicit differentiation is that we know for a fact that if we take the derivative of this e to the y, we're going to end up with a dy dx or a du dx. So we take the derivative of both sides, we get e to the y times dy dx using this principle that we just derived before, and the derivative of the right side is equal to 1. So what that'll give us is that dy over dx is equal to 1 divided by e to the y. And you'll recall that y is equal to natural log of x. So we can go ahead and substitute that back in. Therefore, dy over dx, or y prime, whatever you want to call it, is equal to 1 over e to the natural log of x, which is equal to 1 over x. So put it this way, d over dx of the natural log of x is equal to 1 over x. And this is one that we'll need to memorize, but I'm going to go ahead and put it in a general form like I did the last one. So the general form of the derivative of the natural log is that we have ln of u prime is equal to u prime times 1 over u, which is equal to u prime over u. And this is the general form, and this would be the one that I recommend you memorize. Now let's suppose that for another, let's suppose you have another logarithmic function that is not a natural log. Well, we actually have a rule for this, something we should have learned in college algebra called change of base, that says that the log base b of u is equal to the natural log it's equal to the natural log of u over the natural log of b. So let's go ahead and take an example. And then we can use this to take the derivative. We can use some quotient rule, or since b is a constant, we can just factor it out and take the derivative of that natural log. So let's go ahead and take an example. In our example, we're going to take log base 10 of x. So pretty much it's just a normal log. Log base 10 is generally what we assume, but we're taking the derivative of this, which is going to be equal to the derivative of natural log of x divided by the natural log of 10. And we're taking the derivative of this. Now, if you remember, we can pull out a constant out of our derivative when we're taking it. And natural log of 10 is just a number. So if we take out 1 over the natural log of 10 and multiply it by the derivative of natural log of x, which we already decided was 1 over x, this is what we get. So the derivative of this is equal to 1 over x natural log of 10. Okay, and that's how you would deal with, this is how you would deal with a derivative of a logarithm that is something besides a natural log. Okay, on the same note, we took the derivative of something that is not a natural log. We can also take derivatives of exponents that are not e. So we'll move over here and I'll do it over here. So what if we had something that was not e? Well, there's a general rule we can use. We'll go ahead and use e to the x again, and then we'll do a different example. But if we took the derivative of this, the derivative y prime of e to the x is equal to, and here's the general rule. We write it down, multiply it by the natural log of the base, and then multiply that by the derivative of the exponent. And this is the general rule, and you can see why this ends up yielding e to the x as well, because you take the natural log of e, you simply get 1 because the exponent on e is 1. So this goes off to 1, and you just get e to the x being multiplied by 1. So y prime is equal to e to the x. Okay, so what if we took an example that was not using e to the x? Let's say it is y equals 3 to the x squared. Okay, so what we do is we say write it down, 3x squared times the natural log of the base, which in this case is 3, times the derivative of the exponent, which is 2x in this case. And that's as simple as it is, but that's the general rule for finding the derivative. You write it down, multiply it by the natural log of the base times the derivative of the exponent. Alright, so in the next couple videos we'll be talking about related rates, so some applications. So we'll see then.